All right, we're looking at 4.2, adding, subtracting, and multiplying polynomials. Now, the one that we left off is division, because that's a little bit more difficult, but that's in the next section. All right, right here, the first paragraph here talks about the set of integers being closed under addition and subtraction. This means that the sum or difference of two integers yields another integer. And I'll talk more about that in class, but that is a neat idea, that it's closed. Next up, to add or subtract polynomials, we add or subtract the coefficients of the like terms, right? We just combine like terms. And I'm going to stop reading there. We're going to look down at number 9. These are two different functions, so it's not written out very well, but maybe this is like f of x and this is g of x. And we're supposed to add them together. So I'm going to say 6x squared plus 10x plus 5, and we should probably have parentheses around that to group it together. And we're going to add together 2x cubed plus x squared minus 4x. So there's our function f and our function g, and we're just adding them together. Really, it's just combining like terms. So I'm going to drop the parentheses and combine like terms. I have one cubic term, so that's going to be 2x cubed. Then I look for my quadratic terms. I have 6 and then 1, so that's going to be 7x squared. Then my linear terms, 10 and negative 4, that's going to be 6x. And then I have a plus 5 on the end. So there's our new polynomial, right? We made a new polynomial that was based off of two smaller polynomials, or maybe more simple polynomials. All right, number 10, subtract blah from blah. So we think about if I were to say subtract 3 from 5, I would be saying 5 minus 3, right? I'm going to subtract it from that. So that's what we're doing here. We're going to say 9x squared minus 5, that's one polynomial, minus another one, 2x squared minus 5x plus 3. So to me, this is worded just a little bit odd because we have to put the one that's listed first at the end. So I want to make sure that we all recognize that. This up here, the whole 3 from 5 and the 5 minus 3, that's just an example that I'm trying to give you. So if I subtract this out, I need to distribute that negative there. So this is a little bit more complicated than the previous problem. So the first part, 9x squared minus 5, that doesn't have any change at all. Now I distribute the negative, and I'll have a negative 2x squared plus 5x minus 3. Not too crazy. I distributed this negative that was right here to all three of those terms. Now I combine like terms just like what I did in the previous problem. So my quadratic piece, as a side note, I didn't say this. I look for my highest degree first. That way I can go ahead and write it in standard form. So on this last one, in this one, I started off looking at my cubic. That was right here because he was the biggest degree. If there was something with an exponent of 4, I would have looked at it first. So down to number 10, my biggest exponent is a 2. So I look for my quadratic pieces, the ones with the 2's in the exponents. 9 minus 2 gives me 7x squared. Now I look for my next biggest exponent. That's just going to be a 1. So that's 5x to the 1. So plus 5x. And then I look for my plain old Plano. That's negative 5 and negative 3, which is going to be negative 8. So down here, this is my answer. There we go. Next up, this little blurb just talks about how we multiply. When we multiply, we're going to be using fancy distributing, right? Fancy, kind of like foiling method, right? Whenever you take something up here, right here, I distributed that negative 1. We're going to be doing something kind of similar in this. So number 11, we distribute these. We have two different polynomials here, right? We have a trinomial with 3 terms and a binomial with 2 terms. And for me, whenever I do these problems, I almost always want the one with the lesser number of terms to be listed first. That's just a pattern that probably my teacher taught me, and that's what I'm teaching you guys too. It's not wrong to do it the other way, but I like to do it with the one with the shorter one, shorter meaning the number of terms, first. So I'm going to put this one first because it only has 2 terms. So I'm going to say 2x minus 1 times x squared plus x minus 4. So we're multiplying those. the 2x gets distributed to all three pieces. So I'm going to have 2x cubed, that's from me distributing to the first piece, and then distributing to the second piece, I'm going to have plus 2x squared, and then lastly, 2x times negative 4 is going to be negative 8x. Now I have exhausted my 2x, and I switch over to the negative 1. I'm going to have negative x squared minus x plus 4. And now I've taken care of all of the multiplying. So the rest of it's just combining like terms. So I combine like terms, and again, I look for my biggest exponent first. My biggest exponent right here is a 3, so I'm going to have 2x cubed first. Then I look for my quadratic exponents, so I have 2x squared, or my quadratic terms, 2x squared and negative x squared, so it's going to be just a 1x squared. And then my linear terms, negative 8 and negative x gives me the negative 9x. And then lastly, my constant, 4. And there we go. That's multiplying. Lastly, number 12. Again, we set it up with parentheses, and I like to put my shorter one first. So the x minus 2, that is the shorter one. X minus 2, and then x squared plus 2x minus 5. Whenever I distribute, I'm going to take x times x squared to give me x cubed, and then x times 2x to give me 2x squared, and then x times negative 5 to give me negative 5x. Now there's a trick that sometimes gets used. You can do it like the last one where we just keep on going to the right, and we just make it one long string. So like this guy right here, this was kind of long. There's also, you can set it underneath it. And so I'm going to have negative 2 times negative x squared, and I'm going to put this as a negative 2x squared. And I put that in the column with the quadratic pieces, the x squared. Then next up I'd have negative 4x and then positive 10. What's kind of nice there is I can think about adding them up like this, and sometimes that's a little bit easier, especially if they are much longer. You know, if you had if you had two things with maybe 4 terms or 5 terms, then doing it this way as opposed to the way we did above makes it a little bit easier. So adding these up, and I can just look at the columns. I have 1x cubed, and then my quadratic pieces cancel out, so I just get a 0 there. So here I'll just say 0. So plus 0 minus 9x and then plus 10. And then I'm going to rewrite that a little bit prettier. X cubed minus 9x plus 10. And that's going to be my answer. All right, I think that's the end. Oh, it is not the end. Let's look at the next page here. We have some special formulas that can be useful. I'm going to let you guys read through these, and these are good formulas. They're good formulas to know, but in the very beginning, I think it's best for you guys to just multiply them out like normal. The ones that I find most useful is probably, or are probably, these 3 on the left here. These 2 on the right, I'll be honest, I really don't memorize those. It'd probably be a good idea to memorize them, but I don't use them just because I don't have them in my head. Oops. This first piece here, these guys are conjugates, and we remember that conjugates cancel the middle terms. So it ends up just being the first piece squared minus the last piece squared. That one's probably the most common formula out of all 5 of these that people need to know. All right, let's look at this one down here, number 13. We're supposed to simplify, which means to like multiply or combine like terms. We need to distribute these out. We have 3x plus 4 and 3x minus 4. Now, you might notice, just because we just got done talking about it, that it does fall into this category up here. We have a plus b and a minus b. They are conjugates. So we could just say that it's going to be 3x squared minus 4 squared. And that is correct. That gets you to an answer. But normally, to start off, we just multiply it out like normal, like what we did on the previous page. I distribute out 3x and 3x is 9x squared. 3x and negative 4 is negative 12x. 4 times 3x is positive 12x. And then 4 times negative 4 is negative 16. Combining like terms, we get 9x squared minus 16. And that's our answer here. Scrolling down to number 14, we have x minus 3 cubed. Now, if we want to, we can scroll up here to notice the formula. And we are going to need to use the formula later on in Algebra 2. But for now, since we probably don't have it memorized, I'm just going to multiply this out. And it's going to take a while, but we can still do it just by hand. To cube something means to multiply it 3 times. So I'm going to say x minus 3, and then another x minus 3. And then what we do here is we group 2 of them. So I'm going to group these last 2. And I'm going to multiply those out first. So I'm going to have x minus 3 hanging out front. And then I'm going to have big old parentheses whenever I distribute out. We're going to have x squared minus 3x minus another 3x, and then plus 9 on the end. Now I'm going to combine like terms. So I get x minus 3. This will be x squared minus 6x plus 9. And then I'm going to distribute again. So I distribute x times x squared is x cubed minus 6x squared plus 9x minus 3x squared plus 18x minus 27. And you'll notice that I kind of wrote it in 2 little rows here. That way my ending can be just really simple. I just add them up like this, and I get x cubed minus 9x squared plus 27x minus 27. And there we go. That's our answer to that, number 14. Again, if you wanted to, you could just memorize these formulas. And in fact, that would be a really good thing for you to do, would be to memorize these formulas. But I recognize that sometimes that's difficult, and I think it's always useful to have this long form way to kind of fall back on whenever you forget a formula. All right, number 15. This one here, since it's just a plus, we just combine like terms. So whenever I combine like terms, I'll have 7x to the 5th, right? That's my highest degree. Next up, we have the 4. So that's going to be 10 minus 5, so that's going to be 5x to the 4th. And then our quadratic term plus 3x squared. Our linear terms, negative 5 and positive 2 gives us negative 3x. And then lastly, I have 4 and negative 9 gives me negative 5. And that's it. That's our answer. Number 16. This one is multiplying. So I distribute out and I'll have 4x squared minus 20. Oh, that's not squared, that's cubed. Here, let me write that in red. That's cubed. Minus 20x squared plus 4x plus x squared minus 5x plus 1. Combining like terms, I get 4x cubed minus 19x squared minus x plus 1. And that's our answer right there. All right, is that the ending or do we have more? Oh, that is the ending. All righty, there we have it. Again, I want to go back up to these formulas. These are good formulas to know, and that highlighted one is probably the most important one. That one we really want to know. That one's called sometimes the difference of 2 squares. All right, that was Chapter 4, Section 2.